Good morning. Here we go. So, when we left off yesterday, we were doing breaking a repeating key XOR. And let me get my chat pulled up here in case anybody hops on. Dun, 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 dun. There we go. So we were working on breaking a repeating key XOR. We had gone through the steps of building our Hamming distance function. We had gone through the steps of scoring keys sizes, so like evaluating our most likely key size for our encrypted uh, string. Now that we probably know the key size, so the key size with the smallest normalized distance is probably the key. You could proceed with the 2 to 3 smallest key size or take the key. Okay, so now that you probably know the key size, let's break the blocks of key size length. We've got that. Now we're transposing the blocks, making a block that is the first byte of every block and a block that is the second byte of every block and so on. Yep, we're doing that. So we're in the process of writing the test for that, right? So we're going to write a couple of tests. First, we're just going to take one that is an empty array, and we're going to write a test that says it splits that up into. Um, so actually, do we want? Yeah, that's fine. We can do that. 1, 2, 3, 4, 5, 6. We always know they're going to be 6, right? They're always going to be 6 arrays of blocks, right? Because if we go to our binaries and look, if we're working from hex to from binary, from base 64 to binary, it's always 1, 2, 3, 1, 2, 3, right? Always that. So if that's the case, then what we can do is just do this. We're going to define our interface like this. We're going to take an array of transpose block. Right? And then this is each going to be its own array. And the reason we're doing that is I suspect that we're not going to be combining these. We're going to be single keys XORing them, right? So we might change our mind about this later, but we'll see. So let's write a do block here so we can clean this up a little bit. So do expected result equals this, right? An expected result. And then that's a var dash dash and this. There we go. Okay, a little cleaner. All right, so this function should fail right now. Do I have any broken code anywhere that's going to prevent me from running tests? Well, I don't know. We can just find out, right? Maven test. So happy Friday the 13th on the month of Halloween, everyone. I hope everyone's having a spooky Friday the 13th. Um, my plans are to work on my. I have a workshop I'm going to be helping run next week on um, the MuleSoft portion of a Salesforce workshop next week in Oklahoma City. So expecting to be array size 6, but was 0. Right. Okay, that's fine. We'll fix that. And then, so yeah, I got a workshop next week. It's Initech OKC. If you are interested in attending, you should absolutely sign up. I don't think it's sold out yet. And there are good prizes. In fact, Avio Consulting, the company I work at, is helping sponsor the prizes. Uh, yeah, and then we also, if you saw yesterday that Alex over at the MuleSoft community Twitch stream put up a video yesterday talking about the fact that I'm trying to spearhead the getting started of an exorcism track for DataWeave. So if you go to exorcism.org, it's a site where you can participate in coding challenges. So basically, it gives you a test suite, and your job is to make it pass, and then mentors can look at your code and make suggestions on ways you might improve it and that kind of stuff. And it's all open source and all community driven, not for profit. And they have a number of languages available on there, but they don't yet have DataWeave. So I am currently in the process of trying to get an exorcism track started on there. So let's see what the status is of that. Oh, all right, cool. So they've responded with generic track, exorcism generic track. Post to the support category in the exorcism. Can you discuss this with the team before opening the post? Is worth considering. Is it a program? Anyway, we're gonna do that probably over the weekend while I'm smoking brisket, because that's the other thing I've got coming up. So I'm smoking a brisket this weekend. Okay, so back to code. Scores all key sizes, specs array size 6, but was 0. Right. Okay, so transpose block, transpose block, transpose block, transpose block. There it is. Yep, that makes sense. So we're going to say, so our ACC is actually going to be the empty array, right? 1, 2, 3, 4, 5, 6. Okay. Yep. And we're going to say block split by that is our that's easy enough. Yeah, so let's do a D block right here, right? It's easy enough. Var characters equals sys ACC map item index. We just say, oh yeah, we have item index, right? So we'll say characters. And we're going to say item. There we go. We're just going to type that in there. I think we could probably just zip the two, right? Could we zip the two? What does it do if we do this? This is weird. I actually want to know what it does. So we have an array of arrays, right? 2, 3, 4, 6, right? If I zip that for 1, 2, 3, 4, 6. No, that's not what we want. Yeah, we want to map over that. So if we map that and do 1, 2, 3, 4, 5, 6. Yeah, that's what we're doing. Yeah, we're doing what we're doing. Zip's cute. It doesn't actually solve the problem we have. Okay. So that should make our test pass, right? And then we're going to add a new test that takes an existing block, shoves it into there. This is like not a complicated function. Should be pretty straightforward. Yeah. Hey, green tests. Cool. So let's write another test here. Scores all of the key sizes for a given base 64. No, this is transpose. Transposes the characters in the past string to the target arrays. Works with target arrays already having values in do. So we're going to do a do block. Same var expected result is going to be the exact same thing as this, but with more values in it, right? We're going to say, let's see, 0, 1, 0, 1, 0. Oh, we'll just do a 1. I already typed it. Okay. And then we're going to say transpose block. One. We're going to just grab this block right here. We can just steal this block, right? This is our starting block. All right. And we're going to transpose it with 0, 1, 0, 1, 1. Oh, left a 0 off the end. 0. There we go. 0, 1, 0, 1, 1, 0. Okay. Must equal to expected result. Let's run it. This should work. So at that point, we have our transpose the blocks, make a block that is the first byte of every block, and a block that is the second block of every block, and so on. We've got that working now. Okay. Solve each block as if it were a single character XOR. You already have code to do this. So solve each block as if it was a single character XOR. For each block, the single byte XOR key that produces the best looking histogram is the repeating core XOR key byte for that block. Put them together and you have the key. Okay. All right. So we don't actually want, we want this. We want strings, right? We want a string. We're going to append our string. I was wrong because we're going to just pass the whole string. We're not going to do each character. So we're going to refactor this. We're going to fix our test. This is going to be like that. That. See, I made an assumption. And that assumption turned out to be false. And now I'm playing cleanup. You and me together. Okay, so this is wrong. This is just an array of strings now, right? Miss my vim commands. Okay, and then this is just going to equal to expected result. Okay, so this test now breaks. We're going to break the test, which is fine. We're going to fix it in a minute. While that's running, let's go fix our code. So transpose blocks, going to return an array. Yep, that's wrong. Okay, so this is now item plus plus character at index, right? It's no longer shoveling it onto the end. So we have our characters split by that, and then we're going to have item plus plus. I think that's all only code change we got to make. I think we just switch it from a shovel to a plus plus, and it'll work. Ooh, maybe not. I may have to default item to an empty string, right? Because I'm trying to, yep. It's saying it's trying to plus plus an array onto a string. What is, did I do something wrong here? Oh, this should just be an array now, right? And then what is this gonna be? This is just gonna be an array, right? And then we could just default this, right? We can default this to an empty string. And that should work. No, it won't because ACC. Ah, shoot. 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 Okay, so I can't give it an accumulator if I want. I can't iterate over the accumulator. Actually, the array may be the right way to do it. And then at the end, I just join the arrays. Or join each array, right? What's the best way to do this? Because I want it to not be stupidly unperformant. So I could do this. Let's just do this. Boop, boop, boo, doo, doo. Boop, 3, 4, 5, 6. Build our strings, right? And then that is going to be characters. And then item. We don't need the default anymore. We have the ACC to map over. That's just item plus plus that, right? So this becomes 1, 2, 3, 4, 5, 6. And this becomes what it already is. And that gives us our interface. So let's run that. That should pass. I don't really like making my ACC a bunch of empty strings, but we're gonna. I mean, why not, right? While this runs, I'm gonna grab a drink because it's drink day. It's every day's drink day, but I need caffeine. All right, let's see what our test did. Tests, 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 tests. Green tests. Look at that. We have green tests. Cool. So we did that. We completed this. We're transposing the blocks. And then for each block, treat each block as if it was a single character XOR. You already have code to do this. Right. Right. So for the block, the single byte XOR key that produces the best looking histogram is the repeating OR key for that block. Put them together and you have the key. Right. So so what do we, let's look at our tests real quick. What are we getting back? So we're getting key size and score, right? Key size, single character OR key. Right. So let's go look at our cipher breaks. Repeat SOR break. We have am I using that? Yes, I am. Okay. Am I using hex characters? Yes, I am. Okay. So we're going to score single character or hex string, right? Cool. Hex string. So Oh, it's a binary. Right. So I can just take a hex, score hex string. So I have a hex string. I can just convert it back, each binary back to hex, right? So is this a hex? This is a hex. All these are going to be hexes, right? So these are all going to be hexes. So we map it, right? Um, from binary to hex. From binary to hex. Is that a thing? Binaries from hex to binary. So from hex to binary returns that. From base 64 from binary to hex. So we need to split it by these. Get a hello string into hex from binary to hex. This. So we're gonna have this. Right. Okay. Cool. 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 So we have so we do from binary to hex, right? And that becomes that, right? Um, and then we can do a XOR break here. Score hex string. Yeah. And then, yeah, yep, 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 yep. So we take the binary, convert it to hex. So if I go look at my binaries hex conversion here, from hex to binary table is this, so it needs to be groups of 4. So what happens if I send it from binary to base 64 from binary to hex? Substring every data join by and then split it 4. Okay, yeah, so it's going to take my hex string. Cool, cool, cool. All right. Um, cool, cool, cool. So if I send it an array, all right, so I'll transpose the blocks and make a byte that is the first byte of every block and it's the second byte of every block. Okay. Okay. Transpose the blocks, make a block that is the first byte of every block and a block that is the second byte of every block and so on. Solve each block as if it was a single character X, or you already have code to do this. Right. Um, you know what? This takes an array of strings. So I need each block to be an array of strings, not a string. So we got to go back to what we had before. Um, we have to because we need to pass it for each block. So each block's going to be each of these subarrays, right? And each of these subarrays needs to be an array of strings, not just a string itself. Right? An array of strings. Yep, which is fine because then it'll if I pass it that it's going to join those, right? And then so what happens if I call data weave? If I just have a string and I say join by that, it blows up. It has to be has to be an array. Okay. So that's fine. That's fine. We're gonna do it that way. I had the my initial suspicion was right. So we're gonna do that, and then this is gonna become this, right? That. So this. So that lets us do is call our um, function that it scores. It'll score each of those as a. It'll convert it to hex. So solve each block is okay. Transpose the blocks, make a block that is first byte and block second byte, and so on. Solve each block if it is a single character. You already have coded this. For each block, the single produces the best looking histogram. So it'll be from binary to hex, and then once we have hex, we can do score hex string, right? And then actually we can do from. Can we do from binary to string? Do I have a from binary to string? From string to binary, from binary to string. Binary, find decimal of binary as string. Okay. So, okay. Interesting. So, no, I don't want to do that yet. I don't want to do that because those aren't. Yeah, I want to convert. I'm confused. So, transpose the blocks. Make the block that is first byte of every block and that block is the second byte. Okay, we're doing that. Solve each block F as if it was a single character XOR you already have coded it. Solve each block. Make a block that they have code that scores a. We have a code that scores a block of binary. Score string, score hex string. From hex. So this is going to take candidates as upper string split by 2-point letters, 3-point letters. Okay, 2 pointers. Okay. So so we got to get it into hex. We got to get it into hex, right? We take the binary, convert it to hex. We can do that. Okay. So this is going to become, this is still going to be this, and yeah, I think we're on the right track. We do have to convert it to hex. So that is gonna just become this, right? You gotta have each of these wrapped in an array. Needs to have a new array at the front, or a new square bracket at the front. Okay, so we have an array of empty, an array of these, builds this, builds this. Okay, so save our changes. This should fail. And then it should be a one-line fix to fix it, right? Item plus plus, right. And so this goes back to being an empty array. And this becomes a shovel operator again. And while this runs, I'm going to run to the restroom. I'll be back in a few minutes. Hey, Alex. I'll be back in just a few minutes. All right, I'm back. So, hello, evac baby and Alex. So what we're working on right now, for those who just came in, we're solving CryptoPaths Challenge 6, which is where things get hard. So we're taking a um, we're taking a we're taking this file right here, which is a base 64 encoded um, encrypted and then base 64 encoded uh, value, and we're figuring out the in where we know the algorithm in which it was encrypted, and now we're figuring out how what the encryption key was. So we um, solved for the Hamming distance. We calculated the key size of the key. We figured that out using that Hamming distance. And now that we know the key size, or think we do, we think it is 40 characters based on the score. So we scored 2 to 40 because that's what it said to do. 2 to 40 as potential key sizes for the encryption key. Scored all of those and based on some code that we wrote, and now we are figuring out. Now we've got that score, and we're figuring out the which. So based on the algorithm that we know they use, we're using that to um, solve it. Yeah. So we're at the point now where we just built some code that does this transpose part here. It says right here, transpose the blocks, make a block that is the first byte of every block and a block that is a second byte of every block, and so on. So we've done that. Now we're going to try to solve each single character XOR, which we've already done the code for that in a previous challenge. But in the previous challenge, we were taking hex encoded strings and scoring and solving for those. So now I have to take my binary from base 64 that I've transposed, convert that to hex, and then I take the hex and I'm scoring the hex to figure out the hex, and then I'm going to have to take those and convert them. Well, we'll see in a little bit what. Probably convert it to a string. So we're at the solve each block with a single character XOR step. So let's add a new. So I actually think we can just look at our code here. So we have we're calling we want to call our transpose blocks function here, right? With our accumulator and our chunk. Transpose blocks takes the accumulator and the chunk. So we want to call that function here. Let's move this down here. So we got a little more room to work. So we're going to do this. We're going to say transpose blocks. Transpose block is the name of it. Yep, transpose block. And it's going to take an argument of our accumulator and our chunk, right? And that should give us back an array of our transpose blocks. So we have that. And we're going to, for each block, we need to solve. So it still returns a, so we need to write a new function that, actually, I think we just call our var scored blocks equals, so transpose blocks, and we're going to go over here and score. So we need to create hex strings, right, from our blocks. So hexed blocks, and let's write a function that does that, right? So fun hex blocks, and it's just going to take blocks of binary strings. It's going to be an array, and we're going to return an array, but that array is going to be hex strings, right? Yeah, an array of strings. Okay, so hex blocks, and for now we'll just return an empty array and write our tests because we're test driving this. Okay, so hex blocks, let's go write a test for that. So transpose block, we have a test for hex blocks described by actually, we don't even need, we may not need a function for that because I think we've already set up. So what we're going to have is an array of arrays, and each one of the each index of the top level array is an array of binary string values. So I think we could just pass that that's the block. Like this counts as a block. If we look at our, yeah, so this is a block, this is a block, this is a block. So, and based on our XOR break algorithm, score hex string, single character XOR scores takes a hex string. But we can call, we have a function we wrote called from binary to hex. So we can just call our from binary to hex function over those blocks. So let's do that. Let's do score blocks, right? And we'll just do blocks. And let's do this as scored blocks. All right. And we're gonna say blocks lowercase. We're gonna say blocks map. We don't care about our index. We're gonna call this block, and then we're going to call the from binary to hex block. We probably have to import that function. No, evac baby, I am not looking to spice up my branding. Thank you. You're wasting your time. Let's see. So we're gonna import this from binaries, right? So from binary to hex, right? We've got that. Cool. I make no money from this evac baby, and I have no expectations of doing so anytime in the future. Okay. Go back to our tests. Actually, let's go back to this. So where's our blocks? Score blocks. So we have this. Let's write our test. Quit. Write the test first. So scores a block of binary against the single character XOR character XOR break and do. So we've got do bar expected result is going to be, just do this for now. That's going to be wrong, but we'll figure it out later. Var blocks equals so we're going to need a block of what the heck? We'll just grab this, right? This isn't gonna hurt. This isn't gonna. It's not gonna matter. That's what. We'll just do that. So block is that comma there, and and we're going to call our score blocks with blocks must equal to expected result, right? Okay. So score blocks. Got 10 minutes left. So we've got our blocks. So this is going to fail, but that's fine. We can see what we get from this point. What we should get back is a map of hex characters, right? Expected array size 0 but was 6. Perfect. Okay, so if we go back to our test, let's say expected result is blah. Let's do Empty string, empty string, empty string, empty string, empty string, empty string. 1, 2, 3, 4, 5, 6. Yep. And then run it. We should get something more useful because we're going to get back what the actual hex values are for. So we actually, you know what? 10, 11, 0, 0. We can just look at our. We have so 10. The hex value for 10. Hex value for 10. Ooh, it may need to be 4 characters long, at least in each one. It does need to be 4 characters. It's going to be a bunch of empty. Yeah, so what is this? Test say. C4, so C 1100 4 0 1 0 0 C 8 1 0 0 0. So if I look at my test here, 1 0 0 0 1 1 0 0. I'm interested on why that's. So 1 0. So the first one was 8, all right? So 8 is 1 0 1 1. No, that's B. It's 1 0 0 0. So it actually appended. Interesting. What does it do? Oh, do I right pad those if I need to? I think I do. I think that's actually as expected. So if I do from hex to, so from binary to hex, right pad. Yeah, it's right padding. Okay, so that's why I'm getting those characters. Okay, that's fine. That's fine. That's actually what we expect. So, okay. So 8C40CA, 84COCA. Okay, cool, cool, cool. So, so what is this going to be here? So score blocks. So we actually need to score them though. So we have our blocks. And then we're going to run this against this single character Zor scores hex string. Right? Yeah, we want this function. We're going to call it against this, right? Yep. Let's do this. I don't like that. So we're going to do var hex block equals this, right? And then single character score, say hex block. And we need to import this function from Zor break. So that is ranks : Zor break. Is that right? Oh, it's from. Cipher breaks, cipher break. There we go. Let's say expecting string but got object at. So if I. Oh, well, we'll just take that off for now. Single characters or scores, right? Let's see what we get. This is going to break our test. Evac baby, I'm not interested in your portfolio. If you keep bugging me about it, I'll just block you on here. Okay, there's our scores. All right. Which makes sense that we're not scoring high for any of these because why? Because we just randomly made up some data, right? All right, well, we're at 2 minutes left for the day anyway. That's a good stopping point, but we have the point where we're scoring we're solving each block as if it was a single character's OR. So we're going to do that. We actually might end up just first byte of every block. Okay. Solve each block as if it was a single character XOR. So if I do that, score string, XOR decrypt hex string. Let's just do this. XOR decrypt hex string. Oh, because I have candidates. Yep. Okay. So that's not. So everything scored 0. Because I have a really short string. Okay, that's why. All right, so that's a good stopping point. I will end the stream there because I have to go to a meeting. But folks, have a good day, and we will see you hopefully on Monday. I'm starting a project on Monday, so I may have to reschedule my stream times. Later.